Basic airworthiness and pre-flight inspection. First, we're going to cover why this is so important. You need to make sure that the aircraft is airworthy. And of course, people go, well, what is airworthy? And airworthy is effectively saying that the aircraft will perform as it was designed the day it came out of the factory. If you look in FAR Part 1, which is the definitions, the word airworthy is not listed there. But to repeat, if an aircraft is airworthy, it means that it will perform just as well as it did when it came out of the factory, and nothing is wrong with it. So, no person can operate an aircraft unless it's airworthy. And then, of course, here's the FAA's, one of their catch-all regulations is that the pilot in command, the PIC, is responsible for determining if the aircraft is in safe condition for flight. So effectively, that means that it is the responsibility of the PIC to do a pre-flight inspection and make sure that it is safe for flight. So there's two parts to this pre-flight inspection. One is maintenance records, and making sure that, let's see if I can go in the right direction, making sure that all the right maintenance has been done. And then number two, visually taking a look and inspecting the aircraft before you get in it and go flying. So the first thing we're going to do is we're going to check, we're going to go over what type of maintenance records you might have to pay attention to before you go flying. So Federal Aviation Regulation Part 91 mandates that certain inspections get done. If things are broken, you have to do repairs. FAR Part 91 talks about life-limited components. We're going to get into that. That's parts that when they hit their life limit, you have to replace them. And we're also going to talk about airworthiness directives. And airworthiness directives are kind of like a car recall where something's wrong with lots of different aircraft, and everybody's got to get it fixed. There's also non-mandatory inspections and servicing of the aircraft that usually gets done, but in some cases it's not mandatory, and it'll be a good idea if you know which ones are mandatory and which ones are not. And then anytime work gets done on an aircraft, any kind of maintenance at all, whether it's a pilot doing the work or a mechanic doing the work or a repair station doing the work, FAR Part 43 says that you have to record the maintenance that was done in the maintenance records, and we commonly use the word maintenance logbook to refer to the records where everything is written down that gets done to the airplane. Okay, first we're going to look at inspections. So there's a lot of different inspections, and how often they have to get done or how long they're valid vary quite a bit. First of all, the annual inspection has to be done every 12, it's valid for 12 calendar months, that's why it's called an annual inspection, and it has to be done by a mechanic who holds an airframe and a power plant rating, and then they have to have an inspection authorization. Inspection authorization, effectively you have to have a mechanic, and you don't have to write this down, but you got to be a mechanic for 3 years, you got to be active during the last 24 calendar months, and they got to take some gnarly written tests to prove that you are a super awesome mechanic. And then you can now do an annual inspection, which usually gets abbreviated. Oh yeah, I'm getting the annual done on my airplane next month. You don't usually say the word inspection. 12 calendar months effectively means that, say for instance, if you do an annual in let's say January 3rd of 2017, it's good until the last day of January 24 months later, which would be 2019. So it's just like a lot of other, it's just like the calendar days that we've talked about before, or calendar months rather. Alright, so if I can just get this working the way I want, which seems to be very difficult for me today. All small aircraft, when I say the word any, I'm really talking about small aircraft. For small airplanes, helicopters, blimps, gliders, the annual inspection system is just one of several ways that you can keep the aircraft airworthy using inspections. And that's the one that we're going to talk about the most. In a later chapter, we're going to talk about some other details, about some other ways to maintain an airplane. But this, by far, is the vast majority of small airplanes are in the annual inspection system. Now, there are some times, in addition to the annual inspection, then an inspection has to be done every 100 hours. For instance, we'll get to that here in a second if I can get my pen going. So a 100-hour inspection also has to be done by a mechanic, and this has to be an FAA certified mechanic, just like you're going to be an FAA certified pilot who has an airframe and a power plant rating. But you'll notice they don't have to have the inspection authorization. So they can do this right out of school. As soon as they get out of school, they can do a 100-hour inspection. What's rather interesting is that an annual inspection and a 100-hour inspection are the same inspection, considering what gets done to the aircraft. How it gets inspected, what gets inspected, how well it has to be inspected, it's all the same. What's different, I'm going to see if I can write this up here, what's different between the two is who gets to do it and when you need to do it. Why is that thing moving? And there we go. The 100-hour inspection done by a mechanic with an A&P rating, it's valid for 100 hours of flying time, and then you have to get another one done. So that means it's going to end up getting done more often. Let's say, for instance, you fly out of airport A and you're going to go to airport B, and you fly, and the aircraft is usually stationed or based at airport A. You fly to airport B, and then you look at the maintenance records, and you realize, and let's just say this is a 2.0 hour flight, and you're at point B, and you want to get back to airport A, where you're going to get your 100-hour done, and you realize that you're at 99.0 hours. And if you make this 2-hour flight, you'll end up over here at 101 hours. It's okay to exceed this 100 hours up to a maximum of 10 if you're going to where you're going to get the inspection done. If you're going to where you're going to get the inspection done. So then you can exceed the 100 hours. However, let's say you exceed the 100 hours by 1 hour, then that means the next one is going to be due at 99 hours. So you can exceed it up to a maximum of 10 hours, but you're going to suck that time that you exceeded it out of the next 100 hours. So you can't just keep going to 109 and 109 and 109 and 109. You can't do that. All right, and the good news is if you have an annual inspection done, it counts as the first 100-hour inspection. So you don't have to get an annual and then 2 days later get a 100-hour inspection. The annual counts as a 100-hour. Now, why is one of those three things I wanted to put up here, if I can get this to work. If you're looking at the difference between an annual versus a 100-hour, we already talked about who does it. If you're doing an annual, you have to have an A&P with an IA. When annual inspections get done every 12 calendar months and 100 hours get done every 100 hours, and why everybody has to have an annual inspection done, but you only have to have the 100-hour inspection done if the aircraft is operated for hire. So for instance, let's say you happen to own a PA-38 all by yourself, and you fly it around at the Fresno airport, and you had your annual inspection done in January of 2017. You can fly it around for 500 hours or however many hours you want, and you only have to come back and get the annual inspection done by the end of January of the next year, as long as it's not operated for hire. That is, you can't give rides in it for pay. You can share your expenses like it being a private pilot. But if the aircraft is operated for hire, you have to have the 100-hour inspection done. Now, there is an interesting thing, for instance, like parachute jumping. The airplane is being operated for hire. People are paying money to get in it. You'd have to do an annual inspection on it, and then you'd have to do 100-hour inspections on it. There is an interesting spot where you're doing flight instruction for hire. If the company that is renting you the airplane is also the company that you're paying for the flight instructor, then it's considered flight instruction for hire. If you own your own airplane, or somebody loans you an airplane, or you rent an airplane at a place to rent airplanes, but then you get your flight instructor separately, then that's not considered for hire, and you don't have to have an annual have a 100-hour inspection on it. So let's say I have my PA-38 and I hire a flight instructor to give me a flight review. I don't have to have a valid 100-hour inspection on this because I have the airplane, and that's a different organization than the flight instructor. The automatic altitude reporting system, another name for that is the transponder mode C. The Mode C transponder, that's the part that transmits the pressure altitude inside of your static system. And that has to be inspected, and that inspection is valid for 24 calendar months. And I'm not going to go through the calendar month deal again. But if it's not inspected within the last 24 calendar months, now the inspection is not valid. Now you can't use it. You can't turn the transponder on to transmit Mode C, which means all the places that you want to go flying that mandate a Mode C, you can't go there. So Class C airspace at Fresno Air Terminal, you got to have Mode C. So if you go out to fly an airplane out of the Fresno Yosemite Airport and the Mode C check or the Mode C inspection or the automatic altitude reporting system inspection expired, you can't go. There's also an altimeter and static system check where it checks the accuracy of your altimeter, and it checks the system of pipes or the system of lines that go to the altimeter to make sure that it gets the outside air to measure your altitude. And that inspection also lasts for 24 calendar months. And you need it only if you're doing two things. For instance, if you're flying IFR, IFR stands for Instrument Flying Rules, and of course we are going to be flying Visual Flight Rules with a private pilot certificate. And Visual Flight Rules pretty much means good weather and away from clouds. So if we're just going to fly VFR, then look, we don't need the altimeter static system test done. But if we're at some point we're going to get our instrument rating, we're going to fly IFR, this is going to be a big project. We're going to have this done. And if somebody does maintenance on the static system, then they have to do an altimeter static system check. But you're probably not going to know if they did maintenance on the aircraft to do that because there's no requirement for you to figure that out. And again, I believe I already said that the altimeter static system inspection is good for 24 calendar months. The ELT. The ELT is usually a little orange box in the back of the aircraft. You can't see it. It's usually behind the bulkhead. And it's designed if you have a really, really, really hard landing or you land off field and you decelerate fast, that is you stop fast, the ELT has a motion sensor in it and it will start transmitting on some emergency frequencies, and someone will probably start coming and look for you. That ELT has to be inspected, and its inspection is good for 12 calendar months. So when you're looking through the logbooks to see if all the inspections are done, you're going to be looking for the ELT or emergency locator transmitter inspection and see if it was done in the last 12 calendar months. Also, ELTs have batteries, and although it's not really inspection, it's a life limit. Batteries, it's in FAR Part 91, where it talks about you have to replace the batteries if you've used the transmitter all added together up to 1 hour. So if for some reason it was getting tested, or it went off by accident, and it transmitted all added together, or cumulative, if it was all added together equals 1 hour, then you got to replace the batteries. Or you also have to replace the batteries whenever 50% of their useful life has expired, and that's the life limit of the battery. When you hit a life limit, you got to throw the part away or recycle it. You can't fix it, and that date of the life limit is going to be written in the logbook. So it'll say something like ELT battery due replacement. January 31st, 2020. Hey, talking about life-limited parts, let's talk some more about life-limited parts. Okay, life-limited parts means that when a part reaches its life limit, you have to throw it away. It has to be discarded. You can melt it, you can recycle it, you can throw it in the trash, but you cannot inspect it and put it back on the aircraft. You cannot repair it and put it on the aircraft. There is nothing you can do to that part that makes it airworthy again. It's no longer airworthy when it hits its life limit. Okay, a part that you can use on condition means that it never has a specific moment when, aha, it looks good, but I have to throw it away anyway. That's really what life limit is. You're actually going to take the part off of the aircraft while it's still working and it still looks good, but you're not going to use it anymore because at some point it might break, so you're going to replace it before it can break. On condition parts means that it's never expected to break and that you never have to replace it just because of so many flying hours. And so it just has to get inspected during the annual inspection or the 100-hour inspection. So let's take a look at some PA-38 Piper Tomahawk life-limited parts. Of course, Tomahawks have ELT batteries. Usually those batteries, when they're installed, have a life limit of about 2 years, but it varies based on what battery. The wing on a Tomahawk is designed so that at 11,000 hours, you have to take the wing off and put on a new wing. Now what that effectively means is the life limit here is 11,000 hours. That probably means that it could go to 15,000 hours before it breaks. So there's, subtract 11,000 hours, you've got 4,000 hours of a safety margin there. And that's usually the way life limited parts work, is, like I said, you replace parts before they go bad. There's an steel upper rudder hinge that has to be replaced every 5,000 hours. There's a lower longitudinal trim spring, or trim springs, that have to be replaced every 1,500 hours. The fin spar attachment plate, depending on which ones you've got, have to be replaced anywhere from 3,000 to 5,000 hours. And so these are probably, at least these are the ones all I could find, of the life-limited components in a Piper Tomahawk. This ELT battery is going to be pretty much every airplane out there. And there's a lot of airplanes that don't have these kind of parts, or a lot of small airplanes, so that the only life-limited part on it might be an ELT. But when you start talking bigger airplanes, and certainly when you start talking helicopters, you end up with lots of life-limited parts installed on the aircraft. Now what I want to do for a moment is talk about engine overhaul and a propeller overhaul. And I put the asterisk to remind me that under a lot of conditions flying little airplanes, although the manufacturer may recommend overhauling the engine and the manufacturer may recommend overhauling the propeller, generally speaking, the manufacturer's recommended time between overhaul is only required if the aircraft is operated as an air taxi under Part 135 or is operated in scheduled airline service Part 121. So we're going to be flying airplanes under Part 91, and even if the manufacturer recommends it, we don't have to do it. Now a lot of people go ahead and do it because most of the time it's a good idea, but their engine overhaul, prop overhaul, and a lot of other overhauls like a magneto overhaul is not required under Part 91, even though the manufacturer recommends it. Same thing with an oil change and an oil filter change. Although it's a really good idea, your engine's going to be a lot happier and last a lot longer. You don't have to change the oil and the filter. If the engine has a filter on it, then generally speaking, the manufacturer recommends changing the oil every 50 hours. But it's not really, it's definitely, I got to draw a line in here. See if I can draw the line. These are definitely not life-limited components, but they are things that tend to get done on a certain time basis. Okay, last thing I think we're going to talk about before we talk about the visual inspection are airworthiness directives. Another term for airworthiness directives are ADs. It's very common to be abbreviated ADs. ADs are covered in Federal Aviation Regulation Part 39, which is a federal law, which means they are mandatory. Now, if you have ever heard of a recall on a car, that's where a car manufacturer figures out that they made a car and it had a defect that was in lots and lots of cars. So they try to notify all the owners to say, hey, bring it into a dealership and maybe they'll fix it for free. And it's a good idea because it's usually a safety issue. If you want to drive your car around and you don't want to take it to the dealership and don't get it fixed, that's not breaking the law. But if an airworthiness directive is issued about an airplane or an engine or a propeller or something installed on an appliance like a radio or a tire or a battery or an ELT transmitter, then it's mandatory. You have to fix it. And why are you fixing it? It's because the FAA determines, and this is key here, the FAA says that it's a safety issue and you have to do something about it. Now, the manufacturer may go to the FAA and say, look, we found this defect. We want you to issue an airworthiness directive and make everybody fix it. But they're going to have to show the FAA that it's a real problem. And it could be the other way around. The manufacturer might say, no, it's not that big of a deal, and the FAA decides it is. If it's the FAA decides it is, they will issue an airworthiness directive under Part 39, and then everybody has to do it. And the fix, the thing you have to do on the airworthiness directive, it'll either say you have to inspect it, and then maybe if you inspect it and nothing's wrong, you let it go fly again, and maybe you bring it back in 100 hours, or you bring it back next year. Or it may say you have to make a repair, or also the third thing, it might say that you have to replace the part. You might have to replace the part because the part's no good. So the airworthiness directive itself will say whether you can inspect it, whether you can repair the part, or whether it has to be replaced. And they're going to tell you how long you have to go before you have to inspect it. That is, how much time in service in hours, how many hours is on that part. Or they might say number of cycles. Cycles could be engine starts. Cycles could be the landing gear being retracted or extended. Cycles could be the flaps being extended and retracted as one cycle. It could also well, that's good enough for examples. And then it could also be calendar days, like it could be once every 12 calendar months, once every 60 calendar months. It could be once every day. I actually saw an AD come out where on a helicopter you had to visually inspect the rotor blades every single day, and it was in an airworthiness directive. Okay. If you have a GPS, global positioning system, in your aircraft, and there are some other kinds of radios that also have a database, and that database has latitude and longitudes, it has locations of airports and navigation transmitters and a whole bunch of other stuff. If you want to use it for your primary navigation, you have to have a current updated database. This one here says it expires in March of 06. Of course, if that was March of 3006, that would work out okay. But these usually expire every 28 days or every 56 days. You can go flying if you use it instead of your primary. If you use it as your secondary source of navigation, then it's okay. So if you're looking out the window and you're using your compass and your watch and your E6B and you're using pilotage and or dead reckoning to navigate, and that's your primary source of navigation, then it's okay to use a GPS with an expired database as your secondary source. but you might want to decide to check a few things in the database before you go flying. Okay, now we're going to get to the physical inspection of the aircraft, and I don't even know what that thing over there is. So let's see. Oh, yay, it went away. So the physical inspection of the aircraft. First thing we're going to look at is aircraft documents. They have to be on board the aircraft, and there's a nice acronym called ARROW to help us remember what all those things are. An airworthiness certificate is a document that's issued by the FAA saying this airplane, when it came out of the factory, was airworthy. This is not the same as registration. Oh wait, there is registration. On board the aircraft has to be a piece of paper. It's kind of on cardstock, and it's the registration from the FAA, and it expires every 2 or 3 years. Some states have state registration, which works out great because the word ARROW has 2 R's in it. Some states do and some states don't. If you go flying in a state that has mandated state registration, the FAA can't prosecute you because they can only mess with you because of federal issues. O is for operating limitations. Operating limitations, you have to have placards. Placards is just another word for signs or directions or labels that are on the aircraft. And then you have to have the approved flight manual. If the small airplane was built after 1979, it has an FAA approved flight manual. AFM stands for Approved Flight Manual. There it is, AFM. Sometimes, and a lot of times actually, we call it the Pilot Operating Handbook. But there's going to be one in the airplane. It's going to be the one for that airplane, and it's going to have the serial number of that particular aircraft in it. Now, we're going to have our own copy, but that doesn't apply to any particular airplane. That just applies to all of them. So if there's an airplane, small airplane built after 1979, we're going to be looking for those placards, and we're going to be looking for the FAA-approved flight manual in the airplane that is for that particular aircraft. W stands for weight and balance specific to that aircraft. There's going to be a piece of paper, and usually it gets folded up and stuffed into somewhere into the approved flight manual. Into the approved flight manual. And it's going to say things like exactly how much that particular airplane weighs. And in this semester, when we get to it, we'll talk a lot about weight and balance and figuring out if the airplane weighs a certain amount, how much more stuff can we put on it before we take off. So that is ARROW, or ARROW. That's a famous acronym in aviation. Okay, so let's talk about actually visually inspecting, looking at the aircraft. So a question that comes up a lot is, do we have to do a full and complete pre-flight check, pre-flight inspection every flight? And the answer is maybe. If you are new to the airplane and somebody else has done the flying and the pre-flight inspection, and you go flying and they did it wrong and they missed something, you are still responsible. Remember, the PIC is still responsible for determining that the aircraft is in safe condition for flight. So effectively, if this is the first time that you have flown it that day, you need to go do a visual inspection. But let's just say we fly from one airport, we fly to another airport, and it's 3 hours away. We get out and we get some gas and we get lunch, and then we go back out to the airplane. Do we have to do the entire pre-flight check again? And the answer is, it's up to you as the pilot in command. Generally speaking, if no one else has flown the airplane and you are 100% confident that that has occurred, you go out there and you check the fuel, you check the oil, you look at the wheels, you walk around the airplane once to make sure that nobody's come up and damaged it. But generally speaking, if nobody has done anything to the airplane, the pre-flight check lasts all day, as long as you're the one that did it and you're confident that nobody's done anything to the airplane. So the pre-flight check is in the Pilot Operating Handbook, Section 4. And here are some general considerations that you would think about when you're doing your pre-flight inspection. You would want to remove any temporary covers that were covering up the engine or the windshield or any of the openings on the airplane, like the pedostatic system, so air can get into it, so the airspeed indicator and the altimeter can work. You would remove any wheel chocks. You would remove the chains, the tie downs holding the airplane down, and even small accumulations of frost, ice, or snow. There's actually an FAR that says you can't have any of this. You can't have snow or ice or any frost on the aircraft before takeoff. It has to be removed. And you're looking at the general condition of the airplane. Has anybody run into it with a truck? So you're going to do that every time you go flying, and there's going to be a nice checklist to follow. You're going to be verifying that you can look on the ground for oil leaks or fuel leaks. If you see anything that's discolored due to heat, you might want to do something about it, except exhaust pipes, they're always discolored due to heat. Here's another pipe that looks a little bit on the discolored side. You're looking for dents. Chafing is where two things rub together, and I think I got a nice picture here. Here's something chafed and the rubber part got worn off. Galling is when two metal pieces rub together and metal comes off of one and gets stuck on the other. So you're looking for abnormalities, things that don't look smooth and like they're supposed to. You can look for nicks, you can look corrosion. We can cover corrosion all day long. Here's a nice piece of sheet metal that has made out of steel, and you can see the corrosion, which is starting to turn brownish red. Here's some aluminum corroding. Aluminum, when it corrodes, if it's dirty, it's black, but if it's not dirty, then it can have a white powder, or that might be magnesium. And then, of course, cracks. Here's a great crack in a piece of aluminum. It's a big enough crack you could fit a screwdriver under it. So you're going to be looking for all of these kind of things. And here's a nice crack. You can see this crack right here on this piece of steel tubing in the engine compartment. So fretting is where seams are joined, and aluminum, when it rusts, it can rust under certain conditions where it's a fine black powder. And here the airstream is blowing past it. This is probably on an engine compartment, and this is called fretting. And if you can push on the metal right here, if you can push on the metal and you can see the rivet bouncing up and down, then this is too much fretting corrosion, and you need to tell somebody about it. If you can push on here and nothing seems to move, you're okay. I'd probably wipe it off. But if the aluminum's not wiggling around, it's not bad enough to do anything yet. And of course, we already talked about that. Here's some steel corrosion, and here's some more corrosion on some steel parts. Okay, so you're going to have a checklist, and you're going to follow the checklist when you're doing a pre-flight. And the question is, why use a checklist? And the number one reason is so you don't forget anything. So you don't forget anything. As a pilot, you're going to use a checklist over and over and over again on all kinds of sets of tasks. And it's not that you have to follow the checklist step by step by step. You can do a few items and then go back and see if you got them all. That's an acceptable way to do it. But in the end, you still have to make sure you did everything on the checklist. So here is a list of things that the pilot, although we're talking about pre-flighting the airplane, this is a good place to include it. Here's some things that pilots have to have with them. And you have to bring all your pilot certificates. If you're a pilot with a flight instructor certificate, you got to bring your pilot certificate and your flight instructor certificate. Now, you aren't a certified pilot yet. You're going to be applying for a student pilot certificate, and when you solo, you'll have to have that student pilot certificate with you. You also have to have it needs to be valid, a valid government-issued photo ID. It needs to be valid. So a state driver's license is just fine. You need to have a medical certificate. Again, you don't have to have the medical certificate until you solo, and you have to have it with you whenever you solo, and you have to have it with it whenever you're exercising the privileges of a private pilot or higher. And if you have medical restrictions, like on my medical, it says that I have to wear eyeglasses. So whatever it says on your medical, you have to comply with that restriction. And you only have to have these things during flight training when you're soloing. When you're with your instructor, the instructor is the pilot in command. And you don't have to have any of those things, but I highly recommend you get into that habit pattern immediately of bringing all of these things with you every time you go flying. If you're going to leave the vicinity of the airport, which is generally considered about 5 miles or so, you need to have appropriate charts. If you're going to be soloing, working towards your private pilot certificate, a piece of paper where your instructor said it's okay for you to solo, that you have to have with you. That usually gets written in your logbook, and you take your logbook with you. And if you fly at night, you have to bring flashlight and extra set of batteries, and we'll talk more about that when we get to flying at night. So there's a list of things you have to take with you. This is not a list of everything that's a good idea, like bringing a knee board and some blank paper and some pens and pencils to write with, and bringing a headset is a great idea. Maybe bringing some sunglasses. Some people like to wear baseball caps to keep the sun out of their eyes, especially when they're flying a PA-38 Tomahawk, where the sun shines in from the top. Okay, weight and balance. Covered it just a little bit earlier. I guess I didn't cover it. In any case, weight and balance is talking about the airplane and how much it weighs. And here is our Piper Tomahawk with those funny lines. And people sit in here. They fly the airplane, and their hair sticks up. Okay, and this tail actually goes up, and there's a T-tail on top. So how much does the airplane weigh? The airplane can weigh a maximum amount, but when it's empty, that number is inside. Remember that weight and balance paperwork is inside the airplane, so you as a pilot can look it up. So if you take that and you add in how much fuel you put on the airplane, and then you add in the pilot and all the passengers and their body with their weight, including their clothes, and you add in how much cargo you're putting in the cargo compartment, which in a Piper PA-28 or 38 is not a whole lot. You add them all up, and all of these things together equal the gross takeoff weight. Gross takeoff weight. And this is going to be important because the heavier the airplane, the longer the runway it's going to need to have. The heavier the airplane, the slower it's going to climb. So, and at some point, we're going to reach the maximum certificated gross takeoff weight, and the FAA says you cannot take off an aircraft above its maximum certificated gross takeoff weight. We're also going to talk, you're also going to be, before takeoff, looking at the center of gravity limits. So I forgot to draw the wings in here, so there's the wings. So let's just say the center of gravity, I don't know why that's there. Let's say the center of gravity is pretty close to where the pilots are and the fuel tanks are in there. I don't know why it won't let me draw, but in any case, so here's the center of gravity, the CG. Now if the center of gravity, because you put a bunch of weight in the back, the center of the gravity moves aft, and that's why you're going to have to use trim, but at some point you run out of trim. So the center of gravity can go back a little bit, the center of gravity can go forward a little bit, but there's going to be some limit that the FAA says the center of gravity can't be farther back than this, and the center of gravity can't be farther forward, otherwise you won't be able to control the airplane. So there are limits to the center of gravity, and you're going to be checking that before you take off. The good news is in a PA-38 it doesn't change very much because people are sitting on the center of gravity, so it doesn't move very much. So once you've figured it out, then you don't have to literally get out a calculator every single time. Okay, aircraft performance. Already talked about gross takeoff weight. That's how much the airplane weighs. That's the empty weight of the airplane, all the fuel, all the passengers and the pilot, all the cargo. All of that added together is the gross takeoff weight. And I already said the higher the gross takeoff weight, the longer the runway you're going to need. If there are obstacles out there, you might have to look at how much of a runway do I need to be able to take off and climb and get over the obstacles. Is the wind blowing down the runway at 5 knots, or is it blowing down the runway at 20 knots? If here's the runway, and here's my airplane, oh, there's the wing, and I have 5 knots, I can be doing 60 knots in indicated airspeed, or knots indicated airspeed. but I'm really across the ground, I'm going 65 knots, or I'm actually going less than that. I'm actually going 55 knots. And so I don't have to get as fast before I can take off. What if the wind was going 25 knots? 60 minus 25 is 35 knots. I'd only have to get up to 35 knots ground speed, and I'd be able to get off the ground and start climbing. So the bigger the wind, the bigger the headwind, the less of a runway I need. So you're going to take into account the wind when you're figuring out how long of a runway you need. And you're also going to be figuring out density altitude. Now, I'm not going to go into density altitude too much, but essentially density altitude means that the thinner the air, as you go up in altitude, the air gets less dense, it gets thinner. Then that less air can get sucked into the engine, and your engine doesn't perform as well. It also has an impact on how well your wings generate lift. So in general, the higher you go or the hotter you go, the less the aircraft performs, and you're going to have to take that into account. You're also going to take into account humidity. There's no calculation. You're just going to use a rule of thumb. But at sea level, on a 100-degree Fahrenheit day, which is about 38 degrees Celsius, if it gets to 100% humidity and it's raining, you can actually lose 9% of the engine power due to water vapor is less, due to the humidity is displacing the oxygen, and the engine can't burn the water vapor. So if you've displaced enough oxygen, then the engine doesn't produce as much power. And we're going to talk about performance in a whole nother section. I just wanted to get you understanding the fact that you're going to be responsible as a pilot in command to be checking aircraft performance before takeoff to make sure that you've got enough runway and the airplane's going to climb. Got any questions? Let me know.